The most dangerous assumption in the history of science is that we would know if something were already here, not passing through, not signaling from a distant star. Here, inside the orbital boundary, moving quietly, running on a power source we haven't classified yet. We have never conducted a systematic survey for objects in our solar system that behave with intent. We have looked for rocks. We have looked for ice. We have never formally looked for machines. That distinction has never appeared in any public funding document. That is where this story lives. If you wanted to observe a civilization without announcing yourself, the engineering logic is straightforward. You would not transmit. You would not reflect anomalously. You would match the background noise of a system full of debris and drift in the gravitational corridors where no one looks carefully. Those corridors exist. Lagrange points, the 5 gravitational equilibrium positions in any two-body system, are stable enough to park an object indefinitely without expending fuel. L4 and L5 in the Earth-Sun system have been proposed as survey locations for decades. We have not searched them thoroughly for non-natural objects. That is not a conspiracy. It is a budget decision, which is its own kind of answer. Astrophysicist Ronald Bracewell proposed the concept formally in 1960, an interstellar probe parked in a target system's habitable zone, listening in low-power dormancy until it detected radio output. The Bracewell probe, published, discussed, quietly filed under theoretical. No agency has allocated resources to look for one. That absence appears in no public risk assessment. A patient machine does not need to hurry. If it launched when our atmosphere first became chemically interesting, roughly 2.4 billion years ago, it has had time to arrive from any star within 100 light years. The math does not require faster than light travel. It requires a patience we don't yet associate with engineering. Oumuamua entered the solar system in 2017 on a hyperbolic trajectory, meaning it came from interstellar space. That alone was expected eventually. Everything else was not. It did not tumble like a rock. It accelerated as it departed, beyond what solar radiation pressure could account for, given its estimated mass. Its shape, inferred from the way it brightened and dimmed, suggested something between a flat disk and a needle. It carried no detectable outgassing, the mechanism that produces non-gravitational acceleration in every comet we have ever measured. The standard explanations were published quickly. Too quickly, some researchers noted, before the anomaly had been fully characterized. Avi Loeb, former chair of Harvard's astronomy department, published a peer-reviewed paper in November 2018 arguing that the acceleration was consistent with a thin manufactured light sail, roughly a millimeter thick, a fraction of a gram per square meter. Not a comet, not a rock. The paper did not claim it was artificial. It stated that the artificial hypothesis fit the data and had not been ruled out. The institutional response was to rule it out without ruling it out, to produce alternative models that required assuming physical properties we had never observed in any natural object. That explanation has never made sense to me. The anomaly was archived. Follow-up missions were proposed and not funded. Oumuamua is now beyond the reach of any spacecraft we could launch today. That is the record. Read it again. Read Bracewell's original framing carefully, and the probe hypothesis predicts one specific thing. Silence. Not absence. Silence. A civilization capable of sending an autonomous probe across interstellar space has presumably modeled the development curves of pre-contact species. It would not announce itself to a civilization still burning hydrocarbons and firing projectiles at its own population. It would wait. It would watch. Contact would be initiated only after some threshold, and that threshold is never defined in the literature because we have no data for what it looks like. This reframes the Fermi paradox at close range. The question is no longer why we hear nothing from distant stars. It is why we detect nothing anomalous inside our own orbital neighborhood. The probe hypothesis answers precisely because it doesn't want to be detected. Not yet. If intelligence is distributed, even sparsely, a probe seeding strategy is more efficient than broadcast. One machine per system, indefinitely patient. The silence we read as emptiness may be the operational signature of a strategy running longer than our species has existed. We are not being ignored, we are being assessed. From the inside, those feel identical, which may be the point. If this system contains a probe, its silence carries a specific implication no institutional body has formally examined in any public document. We are not a peer, we are a subject. A forensic observer does not introduce itself to the sample. It records, it catalogues. The indifference is not hostility, it is methodology. And if that methodology is operating here, our solar system is not a home at the edge of a quiet galaxy. It is a cold observation ward, and the attending intelligence has not yet decided we warrant a response. Institutional science handles this poorly, not because the hypothesis is weak, but because the incentive runs in one direction, toward fundable projects, toward answers deliverable in a grant cycle, toward frameworks that do not require reclassifying the entire history of SETI as a search conducted in the wrong direction. Oumuamua in 2017, Borisov in 2019, the Bracewell framework since 1960, each acknowledged, briefly examined, filed without follow-up resources proportional to the stakes. That pattern does not require malice. It requires only that institutions protect their existing models, which is what institutions do. The gap between what we detected and what we funded to investigate has a shape. And the shape is not random. The question this video raised was simple. Would we know if something were already here? The record says no. Not because detection is impossible, but because we have never formally tried, and the one object that demanded an answer was archived before the answer was found. What the probe hypothesis leaves behind is a larger pattern. A solar system full of silence, a galaxy full of silence, and institutions consistently more comfortable funding the search for distant signals than examining what passed through our own backyard. That pattern belongs to an older question. One we'll examine next. Why the rest of the cosmos stays quiet, even when proximity makes silence statistically improbable. If this channel's approach to the record interests you, subscribe. The next piece is where the silence gets harder to explain.